Okay, again, do the graph. Okay, number one is factorization. This is x 3 plus or minus. Es obvio que the domain is all real number except positive 3 and negative 3, que es the restrictions. Well, you can represent like that. Is x so is that, x no, positive 3 or plus or minus 3. It's a one brief way to express this. Another in interval notation, this is equivalent to say from negative infinity, comma, negative 3 to negative infinity. Union, 3 pieces, negative 3, positive 3, union, positive 3, comma, infinity. The range is not easy to see, but I predict after I verification when I see the graph, it's all real number. All real number. Positive infinity to negative infinity. Okay, now the x in a set and y in a set. X in a set is g evaluado en 0, que es obvio que es 0. Entonces one more time happen que es 0, 0 is both, is x in a set and y in a set. Just in case g of x is equal to 0 to find the x in a set. But the problem is that we have fraction, but the fraction is 0 only when the numerator is 0. So we come back to the same idea, x equals 0. So we have only one point, the symmetry. Symmetry y is you replace and the original x for negative x. Let's see what happens. It's minus x over minus x squared minus 9. This is minus x and this is stay positive. So you see compare this and the original, you see that always the y value is opposite sign to the x value. So for the same x, y is opposite. So it's typical odd function. Odd function. D. Okay, now let's analyze the asymptote. I suppose we have two vertical asymptote at x equal 3 and also x equal minus 3. To understand a little bit what is the behavior at this point, you can put the limit when the x approaches to 3 plus of the hour function, and also limited when the x approaches to positive 3 but to the left. Okay. Entonces we're plotting this is 3 over this is 3 plus square minus 9. Now it's easy to see. This is just 3, but at the bottom is 0. 3 plus is a number close to 3 to the right, so a little bit bigger than this. So it's obvious that this is 0 plus, and 3 divided by 0 plus is positive infinity. This is similar. This is 3 over 3 minus square minus 9. Entonces es 3 over 0 minus, because this number is close to 3, pero to the left. Entonces less than 3. Entonces this denominator is negative. Close, almost 0, pero negative. Es negative infinity. Okay, so the idea is clear. In positive 3, we have periodic acetone, and the behavior look like that. I'm using another color. Okay, it go to the positive infinity, and it go to the negative infinity. Okay, let's analyze negative 3. It's similar. You compare the limit, and the x approach it to negative 3 plus. Of the expression is the same. Okay, this is negative 3. This is negative 3 plus square minus 9. Okay, and negative. So this is CS. CS negative 3 plus is in that direction. I suppose it's like a minus 2.99. And when you square, become positive, but it's smaller. Entonces negative. Entonces es negative 3 over 0 minus. Entonces positive infinity. Positive infinity. And the asymptote here, positive infinity. And the limit, when the x approaches to minus 3 left of the x over x squared minus 9 is equal, plug it in, minus 3 over minus 3 minus square minus 9. Okay, this is a number here. Okay, suppose it's minus 3.01 something, huh? But if you square become positive, this is bigger than 9, so it's negative 3 over 0 plus and negative infinity. Okay, this is the behavior, and the asymptote, this is here is positive and here is negative. Okay, this is the topic of the periodic asymptote. Now let's see the horizontal. Horizontal asymptote is the end behavior. End behavior. End behavior mean limit when the x approaches to positive infinity of the function x over x squared minus 9. And why not limit when the x approaches to minus infinity of the x over x squared minus 9. Well, this is easy. This is the dominant, so this x, this is approximately, you know, approximately. Look, this is approximately x over x squared, and this is equal 1 over x squared. We know 1 over x because cancel out. This is 1 over infinity, que es 0. Well, this is exactly the same. No positive 0, negative 0. This is 0. So we have one horizontal asymptote at y equals 0. Okay, now the calculus part. Okay, compare the first derivative. So g prime of x, quotient rule, is equal x squared minus 9 squared. Okay, and derivative the top is 1 times x squared minus 9 minus derivative of the denominator is 2x times x. Okay, conclusion is x squared minus 9 squared, and we have x squared minus 9 minus 2x squared. Okay, when you combine later, it's obvious that we have here minus x squared plus 9 over x squared minus 9 squared. Okay, because actually 1 minus 2 is negative 1. Actually, we have minus x squared minus 9. By your factorization, this negative outside. Okay, nice. Then you try to investigate when this is 0. Impossible. Impossible. No critical about it. No critical about it. No critical. Therefore, vale. No max min. Local. No. However, I saw okay, always this expression is negative. Always a negative. Regardless of the x part. Because it's a square. It's a positive. But this negative affect everything. Now the function is decreasing. Always. Everywhere. Decreasing. Okay. But let's analyze the second derivative. Second derivative is more complicated. You take the expression for the first derivative. Let me copy again. It's minus x squared plus 9 over x squared minus 9 a squared. And you compute now the second derivative. Too heavy. Quotient rule again. Denominator square. F4 power. Square square. Derivative the numerator. But this negative I put outside just in case. It's negative. Derivative is 2x times x squared minus 9 a squared minus derivative. This is complicated. Is 2 times 2 times what? 2 times x squared minus 9. You apply chain rule. The chain rule is derivative. This is 2x. Time x squared plus 9. Something like that. Okay, let me try to apply algebra to my letter. Well, I did my piece of paper. I want to copy the final answer. The final answer is minus x squared minus 9a. So guess common factor here and here. Just I factor out. I factor out 2x minus 2x times x squared minus 9 one time minus 4x 2 times to the 4 x squared plus 9 over x squared minus 9 to the 4 power. Okay, by the way, this cancel when the only one stay 3. Because now you distribute here and combine later. This is 2x cubic minus 18x minus 4x cubic minus 36x. Okay, now combine is negative 2 x cubic plus no minus 54 x 54 36 and 18 together. Okay, now so far, wow, too heavy. Look, sometimes happen get the second derivative. This negative and negative and negative, you eliminate, so it's x ln 2x cubic plus 54x positive divided by x squared minus 9 cubic power. This expression can represent the second derivative. Then force it to be equal to 0 to find inflection points. Well, the only solution that we have, so you take numerator 2x cubic plus 54x factorization is x out 2x squared plus 54 equals 0. One solution is 0 and another solution is complex. You see quadratic one plus is complex. X equals 0 is my potential inflection point. I don't know, I need to testing using the second derivative test. Listen, look, so basically we have a minus 3 one acid and 0 1 hypothetical inflection point and positive 3 another. I select totally randomly testing point for the second derivative test. Suppose que I select negative 4. Suppose que I select negative 2, positive 2, and positive 4. And you evaluate the second derivative. Is heavy arithmetic, but I did using my calculator, of course. And negative 4 is negative 1.003, but it's negative. The important information is the sign. It's negative, but si es negative, is concave down. Entonces now G second prime, evaluating negative 2 is 0.993, is positive, it's concave up. Actually, in negative 3 we have no inflection point, we have asymptote, baric asymptote. And baric asymptote is typical, not always, but sometimes, que change the concavity. In 0, let's see what happens. Second derivative of 2 is negative 0.993. I suppose it's logical because the function is odd function, so when you change the x in the sign, you change the y of the sign. That's the concave down. This is inflection point. This is inflection point. Inflection point. 0. At 0. I testing that. Okay, by the way, the point is 0,0. By curiosity, evaluate the second derivative in 4. It's exactly the same value, but opposite sign 0.03. Therefore, it's concave up. So this change of concavity is normal because it's baric acid. Okay, now ready to go to Desmos verification everything. Okay, this is Desmos of this problem. Okay, you see the 2 baric acid and 2 vertical and 1 horizontal. Okay, the end behavior is in 0. No maximum, no minimum, because the function is always decreasing. It's going down from left to right. Now the second derivative expression is now negative, it's concave down in that interval. And when it's positive, it's concave up in this interval. That's it, no more information in this question.